I'm beginning to record lesson 2.1, which is just simple equations. There is 5 rules that I use to solve equations, and they are: number 1, distribute; number 2, combine like terms; the third rule would be variables on left, constants on right, and then multiply or divide. So I'm going to use put these into play. When you distribute is whenever you have parentheses. There's no parentheses located in this problem, so we'll go on to step 2, combine like terms. What I mean by like terms is if there is 2 like terms, meaning if there's 2 sets of x's on one side of the equal sign, or if there's just 2 constants on one side of the equal sign. We do not have that in this problem. So we're going on to step 3, which is variables on left. I look at find my variable, which is x. Is x on the left side of the equal sign? And it is. So I'll move on to step 4, which is constants on right. I have 1 constant on the right, but I still have 7 and 3 on the left side. What this means, this step is I'm trying to isolate the variable. I'm trying to get x by itself completely. Well, 3 has been multiplied to x. I want to deal with that lastly. But 7 is being added to this. I want to get rid of the 7 and move it to the right side. I do the inverse of what they are doing. They're adding 7, so I will subtract 7. What I do to one side, I must do to the other. 7 minus 7 is 0, so I'm just going to cancel that out. Just mark through it. And now I will simplify this on the right side. On your calculator, the rule is when signs are the same, both negative, you will add these 2 numbers, which is 9, and you will keep the sign. Now I will bring down what I have not used, which is my 3x equals negative 9. This comes down to my last step, multiply or divide. And because they are multiplying by x, I want to get rid of that 3. So to get rid of the 3, I will divide by 3. When I divide 3 by 3, that gives me 1, which cancels it out. What you do to one side, you have to do to the other. So I bring down what I've not used, which is x. Negative 9 divided by a positive. We know the answer will be negative. 9 divided by 3 is 3. I have solved for x to be negative 3. Moving on to number 2. A little bit different. Once again, no parentheses. There's not any variables combined. Variable is on the left side, but all constants are not on the right. So my first step I would do is I want to move this addition of 5 to the right side. I will do the inverse, which is subtraction. That cancels out. What I do to one side, I do to the other. I will subtract 5 from this side. Signs are the same. When signs are the same, I add the numbers and keep the sign. So I'm going to bring down what I've not used. So this is x over 2 equals negative 15. Well, my last step is multiply or divide. What are they doing to that x? They are dividing by the x. So I always want to do the opposite of what they're doing. Because they're dividing by x, I want to multiply. Because they're dividing by 2, I want to multiply by 2. That will cancel. That's like 2 divided by 2, which is 1. It cancels it out. So because I multiplied by 2 on the left side, I will also multiply by 2 on the right side. So what I'm left with on my left side is my x, because that's understood to be a 1. You can put it there if you would like. Equals negative times the positive. We know that'll be a negative. 15 times 2 is 30. I have solved that x equals negative 30. Going on to problem 3. The only difference in this is when I go to look and say, is my variables on the left? No, my variable is on that right side. I have no variables on the left. Whenever you have a variable on the right and not the left, the easiest thing what I would do is I would just go ahead and flip this around. It's still not consistent. It still represents the exact same equation. 3 plus 5x equals 35. So I want to, once again, go through these rules. There's nothing to distribute, combine like terms, and my variable is now on the left side of the equal sign, but are all constants on the right, and they are not. I still have this 3 that needs to go to the right. Because there's not a sign in front of this, that's understood to be a positive, so I will need to do the opposite, which is subtract. 3 minus 3 is 0. What I do to one side, I do to the other. Bring down what you not use. That's a positive 5x equals 35 minus 3, which is 32. Now my last step is multiply or divide. I will divide, because they are multiplying 5 times x. So I want to get rid of that and move it to this side. So I will do the inverse, which is divide. Cancels it out. And what I do to one side, I must do to the other. Now, you can leave this in fraction form. Let's see what 32 over 5 is as a decimal. 6.4. Don't let, just because this has not become a whole number, don't let that disturb you. You could leave it as x equals 32 over 5, or you could change it to a decimal. Just make sure if you leave it in fraction form that it is reduced, and this fraction is reduced. So I have the x equals 32 over 5, or x equals 6.4. Now once again, 4 is very similar, whereas I don't have anything to distribute. There's not any parentheses. There's not any like terms. I'm moving on to my third step, which is variables on the left. Once again, my variable is on this right side. I got to get the x to the left, so that once again I would just go ahead and turn this problem around. So my variable is now on the left. Now I'm trying to get all these constants to the right side. We have to remember what is understood to be in front of this negative x. It's understood to be a negative 1x. So I want to deal with this first. They're subtracting 43, so I will add 43. Cancels it out. What I do to one side, I do to the other. That becomes 53. I bring down what I've not used. This is negative 1x equal sign 53.7. Now, the only difference is that I still have this negative 1 over here. It's different than just a positive 1. I've got to get rid of the negative. So they're multiplying x by negative 1. So I will divide by negative 1. That cancels out. Bring down my variable. X equals a positive divided by a negative is always negative. Negative 53.7. X equals. Now, example 5. 47 equals negative 3 plus 8y. Same thing. Variables on the right side and you get on the left. I'm going to just go ahead and flip this. I'm sorry, I should have put that negative 3 in front. Negative 3 plus 8y equals 47. Okay, so I want to get the constants to the right side. I will add 3. That cancels it out. Add 3. I now have 50. I bring down what I've not used. 8y equals 50. They're multiplying y by 8. So I'm going to divide by 8. Divide by 8. Y equals 50 over 8. Now this will reduce. I know it will reduce by 2. So I'll just go ahead and reduce it by 2. That's 25 over 4. Now will 4 go into 25 equally? And you want to use your calculator to check that. But I agree that it does not go into it equally. So 25 over 4 is your lowest reduced fraction. I'm going to go over a few examples in the workbook that were word problems and I already have listed out. This being the first. A family rents a moving van for $34.95 plus plus 59 cents per mile. The bill is $148.86. So what I'll do first, guys, is that I want to have my initial cost. What does it initially cost to rent this van, regardless if you drive it 1 mile or 1,000 miles? It's going to cost you $34.99. Now, you also have to pay for each mile that you drive. Well, it's 59 cents a mile, so that's going to be 0.59 times, that's our unit rate, times the mile we drive. We're letting X represents the miles that we drive. Equals, the bill is a total, is means equal, remember, $148.86. Now I just have a simple equation like we've been doing. I will subtract and get my constants to the right. So I'll subtract 34.99, move it to the right, and then I would divide by 0.59. You just put that in your calculator. Once again, I don't want the decimals or fractions to disturb you since you have a calculator. So the main part in this problem is to make sure you set it up, because through all these examples we'll be able to work all types of equations. Just want to make sure we can set this up. Now, a plumber buys 20 feet of pipe in February and 30 feet of pipe in March. Now, this pipe is the same type of pipe, so we only need one variable to represent the pipe in February and the pipe in March. But he spent a total of $384.45. What is the cost of the pipe per foot? So we're going to take this pipe that he bought in February, which we don't know. We do know how much it is. How much he bought. He bought 20 feet in February. But we still don't know what that cost per foot is in February. And then, on top of that, additionally, he made another purchase when he bought pipe in March. And that pipe, he bought 35 feet of pipe in March, but we still do not know the cost. But we know he spent a total of $384.45. Well, since this is the same type of pipe, the price was not changing. And I know sometimes it can, but possibly this problem should have given a little bit of more information, but that's why you have me here to walk you through it. So 20 is so it would be 20 times C, so 20C, that represents the pipe he bought in February, plus 35C, which represents the pipe he bought in March, is a total of $384. This is where we go on into our second steps, which is combine like terms. Like terms means I have a variable and a variable, which is the same variable on one side of the equal sign. Therefore, I combine that. I just take 20 and 30 and add it together, 55, and I keep that 1C. I bring down what I have on the right side. Then I go on down to variables on the left, it is, constants on the right, all besides of 55. What is being done to C? C is being multiplied to 55. I've got to get C by itself. I've got to isolate the variable. So I'll divide 55 by 55. That cancels out and just leaves me with C. What I do to one side, I do to the other, and I get 6.99. Once again, the main point in that problem was to just set it up, because we will get into the next lesson. It's going to introduce us all into combining like terms. Here's a few more examples. You can pause. And this will complete lesson 2.1, solving two-step equations.